We're about to show you how this outboard engine will transform boating forever. And I'm not talking about some far-off concept motor that runs on unicorn tears and good intentions. No, this thing exists right now. Imagine this, you're sneaking up on that secret fishing spot at dawn, and your motor is so quiet the fish don't even know you're coming. But here's the kicker. While everyone's focused on Tesla cars and electric bikes, there's another revolution happening on the water, and most boaters don't even know it yet. What if I told you that the future of boating doesn't smell like gasoline, doesn't wake up the entire marina, and could actually save you thousands of dollars while unexpectedly making you the envy of every old-timer at the boat ramp? You know, folks, we've been burning dinosaur juice in our outboard since Ole Evinrude slapped his first motor on a rowboat back in 1909. That's over a century of basically the same technology. Sure, we've added fuel injection and made them cleaner, but we're still mixing gas and oil like we're making a really expensive salad dressing. The electric outboard revolution didn't happen overnight. It started with glorified trolling motors that couldn't push a rubber ducky across a bathtub. But something changed around 2005 when a German company called Torqeedo decided to get serious about electric propulsion. They weren't the first to try, but they were the first to make people actually pay attention. Here's where it gets interesting, and a bit controversial. The marine industry has been dragging its feet on electric power way longer than the auto industry. Why? Well, when you've got dealers making bank on annual winterizations at $300 a pop, oil changes every 100 hours, and fixing carburetors that mysteriously gum up every spring, there's not exactly a rush to sell motors that need almost zero maintenance. But the times, they are a-changin'. The real breakthrough came with lithium battery technology. See, the old lead-acid batteries were like trying to power your boat with a bag of rocks. Heavy, inefficient, and about as exciting as watching paint dry. But lithium, that changed everything. Suddenly you could pack serious power into a package lighter than a case of beer. Now let me tease you with today's star of the show, the Newport NT300 3-horsepower electric outboard. This little powerhouse weighs just 23.8 pounds, runs quieter than a church mouse wearing slippers at just 40 decibels, and can push your boat up to 66 miles on a single charge. Imagine that, 66 miles. That's like going from Manhattan to Philadelphia. Okay, maybe not quite, but you get the idea. But here's what really gets my propeller spinning. This motor puts out 1,300 watts of pure electric power, equivalent to about 3 horsepower in gas motor terms. It's got 110 pounds of thrust. That's more than some 5-horsepower gas motors deliver. The NT300 isn't just another electric motor trying to compete with gas. It's got field-oriented control technology that sounds like something from Star Trek, but actually just means it's constantly optimizing its magnetic field for maximum efficiency. Think of it like having a transmission with infinite gears, always in the perfect ratio. We'll dive deep into all the juicy specs, real-world performance tests, and even some installation tips in just a bit. But trust me, what makes this motor special isn't just the numbers, it's how those numbers translate to your actual time on the water. Hey, if you're enjoying this deep dive into the future of boating, hit that subscribe button and ring the bell. Trust me, you don't want to miss what's coming next, including a side-by-side comparison that'll blow your mind. Before we get our hands dirty with the Newport, let's talk about the elephant in the room. Or should I say, the motors in the marina. The electric outboard market has become a battleground, and the competition is fierce. So who's who in the electric zoo? Well, you've got Torqeedo, the German grandfather of the industry. They've been at this since 2005, and their travel series is like the Mercedes-Benz of electric outboards: sophisticated, expensive, and occasionally temperamental. Their latest Travel 1103C will set you back around $3,000, but it comes with GPS integration, range calculation, and enough tech to make your smartphone jealous. The 915 watt-hour battery gives you solid range, but here's the catch. Some users report the plastic components don't hold up as well as you'd expect for the price. Then there's ePropulsion, the Chinese upstart that came out swinging in 2013. Their Spirit 1.0 Plus is probably the Newport's biggest competitor. And here's where things get spicy. They pioneered the direct drive technology that Newport also uses. No gearbox means fewer things to break, and it runs smoother than a jazz saxophone. At $1,999, it's priced to compete, with a 1276 watt-hour battery that's actually 30% larger than Torqeedo's latest offering. The battery even floats if you drop it overboard. Try explaining that to your insurance company with a gas motor. Mercury. Yes, that Mercury finally woke up and smelled the lithium with their Avator series. Their 7.5e is their entry into the 3 horsepower equivalent game, and while it looks prettier than a sunset over the Gulf, at $3,575, it's asking champagne prices for what might be beer performance. It's also heavier than a guilty conscience at 60 pounds with the battery. That's nearly triple Newport's weight. And then there's our Newport NT300, sliding in at a price that varies significantly depending on where and when you look. The manufacturer's suggested retail price started at $999 when it launched early in 2023, but current market prices range from $1,199 to $2,339 depending on the dealer, region, and whether batteries are included. International markets like Australia see consistently higher prices, around $2,300. Even at the higher price, it's still competitive, and if you can find it at the lower end, it's an absolute steal. Let's talk dollars and cents, because I know that's what's really on your mind. Sure, electric motors are whisper quiet and environmentally friendly, but can they compete with good old gasoline when it comes to your wallet? Here's the uncomfortable truth the gas motor companies don't want you to hear. Over 8 years, the total cost of ownership between a 3 horsepower electric and a 3.5 horsepower gas outboard is virtually identical. The ePropulsion folks did the math, and while their Spirit 1.0 costs $1,999 up front, compared to about $1,100 for a Mercury 3.5 horsepower 4-stroke, you save about $1,010 in fuel costs over those 8 years. But let's break this down even further with the Newport. Say you use your motor 100 hours per year. That's pretty typical for a weekend warrior. With gas at $4 per gallon and a consumption rate of about 0.3 gallons per hour, you're looking at $120 per year in fuel. Electricity. At the national average of 13 cents per kilowatt hour, charging that 36-volt battery costs about $1.50 per full charge. If each charge gives you 4 hours of runtime at a moderate speed, that's $37.50 per year in electricity for the same 100 hours. That's savings of $82.50 per year just on fuel. But wait, there's more. I always wanted to say that. Factor in the maintenance, oil changes at $30 each, spark plugs at $20, winterization at $300, that mysterious $400 repair when water gets in the lower unit, and suddenly that electric motor starts looking like a financial genius move. No oil changes, no winterization, no fuel stabilizer, no impeller replacements, no nothing. Just plug it in like your phone and go. The Newport NT300 takes this even further. At the lower price point of $1,199, you're looking at breaking even with a gas motor in about 3 to 4 years, assuming you use it regularly. After that, it's all gravy, baby. And here's something nobody talks about: the resale value. Electric motors hold their value better because there's less that can go wrong. No compression to lose, no power head to rebuild. Alright, let's get real about the pros and cons, because nothing's perfect, not even my wife's meatloaf, though don't tell her I said that. The good. Electric outboards are so quiet you can literally have a conversation at normal volume while cruising. At 40 decibels, the Newport is quieter than a library. No more shouting, "What?" every 5 seconds. They're instant on, instant reverse. Twist the throttle one way for forward, the other for reverse, with no gear shifting or clutch dogs to worry about. The Newport can throttle down to speed so low you'd think the motor died. Perfect for trolling or sneaking through no-wake zones without fouling plugs. The maintenance schedule, there isn't one. Seriously. No oil to change, no gear lube to replace, no water pump impellers to swap, no zincs to check. The only thing you need to do is keep the prop clean and occasionally wipe down the motor. That's it. The bad? Range anxiety is real, folks. While the Newport claims up to 66 miles, that's at about 2 to 3 miles per hour, basically trolling speed. Crank it up to full throttle and you're looking at maybe 4 to 5 miles before the battery's crying uncle. Real-world testing shows you'll get about 2 hours at half throttle with a 30 amp-hour battery, which translates to about 10 miles at 5 miles per hour. And here's the dirty little secret. Charging infrastructure on the water is about as common as honest politicians. Most mariners are still living in 1982 when it comes to electrical hookups. You'll find 30 amp shore power for big boats, but convenient charging stations for electric outboards. Good luck with that. The battery math nobody explains. The Newport requires a 36-volt system with a minimum 30 amp-hour capacity. You've got options: one 36-volt lithium battery, about $800 to $1,200. 3 12-volt lithium batteries wired in series, about $600 to $900 total. Or if you're really budget conscious, 3 12-volt AGM deep cycle batteries wired in series, about $450, but twice the weight. Note that while the motor operates on 36 volts, it cannot use standard 24-volt trolling motor batteries. You need the full 36 volts. Here's the kicker. Battery capacity ratings are like EPA fuel economy estimates. Your mileage may vary. That 30 amp-hour battery theoretically gives you 1,080 watt-hours, 36 volts times 30 amp-hours. The motor draws 37 amps at full throttle, which means about 1,332 watts. Do the math, and you get about 48 minutes at wide-open throttle. But who runs full throttle all the time? At half throttle, about 600 watts, you're looking at nearly 2 hours of runtime. Here's where things get interesting, and a bit political. Several European lakes have already banned gas motors entirely. Lake Constance, straddling Germany, Austria, and Switzerland, went electric only. California's considering similar restrictions for certain waterways, and several national parks already prohibit gas motors on specific lakes. The writing's on the wall, folks, and it's written in battery acid. But here's the controversial bit that the marketing departments conveniently forget to mention. Manufacturing these lithium batteries isn't exactly green. It takes about 125 kilograms of CO2 to produce each kilowatt-hour of battery capacity. For a typical 36-volt 30 amp-hour battery, that's about 135 kilograms of CO2, equivalent to burning about 15 gallons of gasoline. However, and this is a big however, you make that back within the first year of use. After that, you're running virtually emission-free. The EPA estimates that a single 2-stroke outboard produces more pollution in 1 hour than a modern car does driving 5,000 miles. Let that sink in. Your little 3 HP motor is basically a floating Volkswagen diesel scandal. And it's not just about global emissions. Every time you run a gas motor, you're dumping unburned fuel directly into the water through the exhaust. Studies show that up to 30% of the fuel in older 2-strokes goes straight into the water unburned. Even modern 4-strokes release pollutants. Electric, zero water pollution. Zero. Zilch. Nada. Alright folks, here's your second chance to join our boating revolution. Smash that subscribe button and drop a comment about your worst gas motor horror story. I'll feature the best ones in next week's video about DIY electric conversions. The future of outboards is moving faster than a bass boat at a tournament weigh-in. We're seeing solid-state batteries on the horizon that could double the range while halving the weight. Toyota's working on batteries that charge in 10 minutes and last 20 years. When that technology hits marine applications, game over for gas. Wireless charging pads built into docks are already testing in Norway. Imagine pulling up to your slip and your motor starts charging automatically. No plugs, no cables, just park and charge. And get this, regenerative charging while sailing is becoming standard on higher-end models. The ePropulsion Spirit 1.0 Evo already offers it, turning your prop into a generator when you're under sail. But here's what really excites me: the integration possibilities. The Newport's digital throttle already shows battery levels, speed, and power consumption. Next-generation models are adding GPS integration, smartphone apps for diagnostics, and even autopilot capabilities. Imagine setting a waypoint and having your motor automatically adjust speed to maximize range. Solar integration is getting sophisticated enough that you could theoretically never plug in if you're a casual user. Flexible solar panels that conform to boat surfaces can trickle charge your batteries all week, ready for the weekend. A 200-watt panel can fully charge a 30-amp-hour battery in about 2 days of good sun. The problems facing electric outboards aren't really about the motors anymore. The motors are fantastic. It's everything else: charging infrastructure, battery technology, and most importantly, boater mentality that needs to catch up. But that's changing fast. Marina owners are starting to realize that offering charging stations attracts an affluent, economically conscious clientele who spend money. Let's talk about how the Newport NT300 actually performs when the prop hits the water. I've compiled data from real-world tests across different boat types, and the results might surprise you. On a 12-foot aluminium John boat with one person aboard, total weight about 350 pounds, the NT300 pushed it to 5.2 to 6.5 miles per hour at full throttle, depending on conditions. Newport's FAQ lists the top speed as 5.2 miles per hour, while real-world tests have seen up to 6.5 miles per hour in ideal conditions. Drop to 75% throttle and you're still doing 5 miles per hour, but extending your range by 40%. At half throttle, the sweet spot for efficiency, you'll cruise at 4.2 miles per hour and can literally go all day. Load that same boat with 2 adults and gear, 600 pounds total, and full throttle speed drops to about 5.2 miles per hour. Still respectable, and honestly, how often do you need to go faster in a 12-foot boat? This isn't a bass boat, it's transportation. On an inflatable dinghy, the bread and butter of electric outboards, the performance really shines. The lightweight means better speed and range. A 10-foot inflatable with one person can hit nearly 7 miles per hour and cruise at 5 miles per hour for hours. Try doing that with a 2-horsepower gas motor. But here's where it gets interesting: the torque curve. Gas motors need to rev up to make power. The Newport delivers maximum torque from 0 RPM. What's that mean in real life? Instant acceleration, no bog down in weeds, and the ability to push heavy loads that would stall a similar-sized gas motor. Look, I'm not here to tell you to throw your gas motor in the trash tomorrow, but if you're in the market for a small outboard, or if you're tired of waking up the whole lake every time you launch at dawn, the Newport NT300 deserves serious consideration. At its price point, especially if you can find it at the lower end of the range, it's not just competitive, it's disruptive. This isn't some greenwashed toy for eco-warriors. It's a legitimate alternative that happens to be better in many ways than what we've been using for a century. The motor itself is solid. Brushless motor technology is proven. It's in everything from computer fans to Tesla cars. Direct drive eliminates complexity. Field-oriented control maximizes efficiency. The lightweight design makes it practical. The near-silent operation makes it pleasant. The zero-maintenance reality makes it economical long-term. Is it perfect? No. Range limitations are real. Charging infrastructure needs work. Battery costs add to the initial investment. But remember, every new technology goes through this phase. The first cars had to compete with horses, and people complained about the lack of hay stations. The revolution isn't coming, folks. It's already here, humming quietly at a dock near you. The Newport NT300 represents the democratization of electric boating. It's affordable enough to take a chance on, powerful enough to actually use, and reliable enough to depend on. Whether you jump on board now or wait for the next generation, One thing's certain, the days of mixing gas and oil are numbered, and that number is getting smaller every year. In 5 years, we'll look back at gas outboards the way we now look at carburetors, quaint reminders of a messier, noisier, more complicated time. So what do you say? Ready to join the silent revolution? Hit that subscribe button one more time, give this video a thumbs up if you learned something new, and drop a comment telling me about your dream electric boat setup. Are you ready to make the switch? What's holding you back? What questions do you still have? And remember, keep your batteries charged, your props clean, and your mind open to change. The future of boating is electric, and it's arriving one quiet motor at a time. This is your captain signing off, and I'll see you on the water, though you probably won't hear me coming.